want to try to put together a quick overview of problem number 79 in case you weren't in class on Friday to look at that. The reaction is starting here with, let me switch to a highlighter, I think. Starting with this compound that we know contains hydrogen and carbon, but we do not know the formula. We are told, however, that when we burn it, it produces this much water. So the real key for being able to solve this problem is being able to know what the mass of oxygen and hydrogen are in the hydrocarbon cumene. Well, we can figure out the mass of carbon or the mass of hydrogen in the water. And if we could tell the mass of hydrogen in the water, we know that its mass all came from the cumene. That's the only place in this equation we have hydrogen. So once we know the hydrogen in the cumene, we can also calculate the carbon in the cumene. And so on this slide, what I have here is the 42.8 milligrams of water. That's the amount of water we started with. The amount of water that was produced in this reaction. So as we start with that number, we're going to convert that to grams. Milligrams cancel out here. This part right here that's highlighted in yellow is a very important part because this is where we get it's basically the percentage of hydrogen that is in water. I've got here the molar mass of the molar mass of hydrogen divided by the total molar mass of water, and that gives us the mole fraction actually of hydrogen in water. So we convert that moles, where are we at here? Milligrams canceled, grams canceled. I'm converting that back into just milligrams of hydrogen. So I have this right, milligrams of hydrogen in the water. But remember, that's the same as the milligrams of hydrogen in our original compound. So now from the 47.6 milligrams of cumene, we know that 4.77 milligrams of that was hydrogen and 42.8 milligrams was carbon. So we now can just solve for the empirical formula. Take that mass of carbon, find out how many moles of carbon we have. That mass of hydrogen, find out how many moles of hydrogen we have. Find the mole ratio by dividing by the smallest number of moles in both cases. That gives us a ratio of 1 to 1.33. But this is not a nice, neat whole number ratio, so that is not going to work for us. We have to now multiply this column by some factor that will give us a whole number. So I look here at the 1.33 and I say, what small factor can I multiply that by to get a whole number? Well, that ends up being 3. So if I multiply that by 3, I also have to multiply up here by 3. That gives me a ratio of 3 carbon to 4 hydrogen. So my empirical formula is C3H4. That's the empirical formula. So how do I get the molecular formula? Well, this is the mass of the empirical formula, 40 grams. It's a little more. It's like maybe 40.04 or something like that, but really close to 40 grams. And we were told that the molar mass of the molecule was 120. So I know that I'm going to have to multiply by a factor of 3. So that means I just multiply my empirical formula by a factor of 3 as well, giving me C9H12. Sounds like things are getting exciting here. Time to sign off.